Okay, if you missed class today, some things to remember is we have a little bit less than 2 more weeks before the quarter is over. At this point, we only have about a week and a half. So if you need help, ask for help. And then some common things that were incorrect on the acceleration quiz was remember that there are three different ways for acceleration to happen when an object is speeding up, slowing down, or changing directions. This question refers to the challenge question from yesterday that has to do with the swallow. So the initial velocity was 2 meters per second, and the swallow accelerated for 2 meters per second squared for 4 seconds. Because we are looking for velocity of it at the end, we are going to use the final velocity equation, which is final velocity equals initial velocity plus acceleration times time. Plug it all in together, and that gives you 10 meters per second for final velocity. The distance versus time graph for acceleration is a quadratic pattern. It was a little bit of a mix-up yesterday when it came to students identifying this. I think where a lot of you got confused was that we also had the velocity versus time graph, which showed a linear line. So that has to do with velocity versus time, and that's just to show that with that acceleration is the slope. However, when we're talking about acceleration specifically, that is a quadratic pattern. Opportunities to make up quiz points. There's actually two ways that you can do that. If you missed like one or two that you just want to fix, you can always do the test corrections. Or if you miss more than 5 points, you can do the test corrections as well. That form is on Google Classroom. This is a Google Classroom acceleration quiz follow-up. This form, it looks like this. You can earn up to 5 points back. It's not guaranteed. It's dependent on how accurately things are done. And then the max points that you can get on this quiz is 16 out of 15. For today, we're going to focus on this learning target, which is I can program Google Sheets to use to solve complex situations. Yesterday, we started doing the mini lab practice programming. So the reason why we are doing these practice programming is because, or just programming in general, is because programming the spreadsheets can make it so that it does the math for us, which then speeds up the process than us sitting here calculating things by hand. There is a video linked on the Google Classroom assignment. If that doesn't work, the video is linked down here where Mrs. Davidson gives you a step-by-step directions that you can just follow exactly and type in exactly what she is typing. So a couple programming vocabulary words for you is, so this little box is called a cell. So whenever we're talking about cells, it refers to the individual boxes. This is called a column, and the columns are labeled by the letters. And then a line of this is called a row, and the numbers label the rows. So if I'm talking about B2, that means I would go over to column B and go down to row 2, and this would be the cell right here that I would be focusing on. This one right here, since it's already highlighted, would be A1. Okay, and so whenever we're talking about A1, B2, whatever, it talks about the individual cell in a specific location. So this video, you can watch it if you would like. I think there is one cuss word on it. So if you don't like cuss words, don't watch it. But it's the Try Guys. And what they did was they did a video seeing how distracted driving affects the driving process in general, or whether or not it even affects it. It's a pretty cool and funny video. If you want to watch it, you can. If not, you don't have to. Oops. No. All right. So back to our main point about texting and driving. This can actually be broken up into 3 phases, 3 chunks, 3 puzzle pieces, however you want, categories, however you want to phrase it. We have the distracted phase, the reacting phase, and the braking phase. The car travels at a certain distance during each of these phases. And then to find the total distance, we need to add up the distance from each phase, which then gives us total distance equals distracted distance plus reacting distance plus braking distance. All right. The example scenario that we're going to talk about is this one. The car is traveling at 12 meters per second. The driver is distracted for 0.4 seconds. Then they take 0.8 seconds to react. The acceleration rate for braking is negative 8 meters per second squared. We're going to find the total distance that the car travels before coming to a stop. So this is we call this a system analysis, where it shows all of the different steps broken down so that we can easily see all the different moving pieces that it takes to figure out this problem. So we're actually going to do all of these different steps right now. Step 1 is the distracted phase. This phase, the car is not yet braking and is still moving at a constant velocity. The equation that we're going to use to find this distance is distance equals velocity divided by time. The knowns that we have is that velocity is 12 meters per second and distracted time equals to 0.4 seconds. So when you multiply that together, we get that 12 meters per second times 0.4 seconds gives us 4.8 meters. That 4.8 meters is our distracted distance. Step 2 is to find our distance at the reacting phase. So during the reacting phase, the car still has not started braking. It is still at a constant velocity in motion. And we are still using the same equation, distance equals velocity times time. The knowns that we have is that velocity is 12 meters per second. That hasn't changed from the distracted phase. And then our reaction time is different from the distracted time, which is 0.8 seconds. Multiply those two together, and we have 9.6 meters. So at this point, we know that distracted distance was 4.8 meters, and our reacting distance was 9.6 meters. Our next step is to figure out our distance for the braking phase. So during the braking phase, the car is officially starting to slow down. So there is a constant acceleration. Remember, acceleration occurs when there is a change in velocity. So the change in velocity is the car slowing down, which creates a constant acceleration. And if we all remember, negative acceleration can be thought of as deceleration. The equation that we're going to use is different than the other two because there is acceleration that is involved now. So braking distance is equal to 1/2 times acceleration times time squared plus starting velocity times time. Yeah, it's kind of a mouthful. So we know that acceleration is negative 8 meters per second squared, and starting velocity is 12 meters per second. What we don't know is time. So before we can even find the distance of the braking phase, we have to go and find time. So braking time is equal to final velocity minus initial velocity divided by acceleration. So my final velocity is my stopping point. I want the car to come to a complete stop, which means that that final velocity is 0 meters per second. My starting velocity is still 12 meters per second, and my deceleration rate was -8. Solve for that, and I found that my braking time was 1.5 seconds. Okay, now that I have that, I can go back and plug it into my equation to solve for the braking distance. Plug it all in, divided, add, subtract, all those different pieces. That gives me 9 meters. So I now have the distances for braking distance, reacting distance, and distracted distance, which means I can find my total distance. When I add them all together, that gives me 23.4 meters. So, why do I even care about these things? It is very common that people who are more experienced drivers, as they like to call themselves, say that they have very good reaction time or that they can stop in time, all those different pieces. So, why do we care about actually trying to think about the distance that it takes for a car to come to a stop with distraction, reaction, and the braking distance? Well, we are trying to develop a better understanding about how the world works. Science can be applied to our daily lives, something as simple as seeing how a car stops, or like the distance it takes for a car to stop. More specifically, um, it assesses risk factors. It helps us better understand why things happen the way they do. So now we know why it takes such a big distance for a car to stop, because there's a lot of different things that come into play. And then it helps us understand why laws and policies get created. So just thinking about things like the texting and driving law, before that was not a big thing. I would say within like what, the past 5, 6 years, it became a really big thing that people are pushing. And nowadays, if you are texting and driving, you're gonna get fined. You're gonna get pulled over, and it's not gonna be fun. And more importantly than not, all of these things help us change our way of thinking by using evidence that we got from science to help support it. Okay. So we're always trying to adapt, we're always trying to change. Got to remember why all of this applies and affects us. This is an example of a program sheet. So this was a complex problem that took quite a while for us to do. Just by hand, a little bit quicker than most just because I had it already pre-done. We can actually program Google Sheets to find the distance for any set conditions. So if I opened up my example Google Sheet that I have, I plugged in all of my different numbers, and it tells me immediately, oh no, this the distance to the walker was 10 feet, and they got hit. Whereas, let's see, what would happen if I started to change my numbers where, let's see, I wasn't distracted at all. My number right there gets changed. And when you add it all together, they still got hit, even without distraction. Let's say they reacted a lot faster too. Oh, this person still got hit. Well, that's just an example of a program spreadsheet and how it can change. Let's say I change my distance of my walker to, let's say, 50 feet. Oh, look, they didn't get hit, but I will show you how to do this at a later time. Oh, wait, before we stop, what you need to work on today. If you have not finished up your mini lab practice programming, you need to do that. If you want to make up points for your acceleration quiz, go ahead and do that. If you have not taken your acceleration quiz, go ahead and do that. And remember to do any missing work that you have, and no school tomorrow.